Today I am going to talk about the chemical reaction and nuclear reaction. But we are not going detail about the chemical reaction and nuclear reaction. We are going to differentiate chemical reaction with nuclear reaction in terms of 5 important or basic points. Okay, let's start. Chemical reaction. In all the chemical reaction, electrons of the atom takes part. It means electrons are responsible for the chemical reaction. Whenever an element reacts with another element or compound reacts with each other, then the atoms of the element takes part in the reaction, and particularly the electrons of the atom takes part in the chemical reaction. Either the atom donate the electron to other, or an atom gains electron from other, or atoms share electrons with each other. In this way, gaining or losing or sharing the electrons of the atoms of the element, they take part in the chemical reaction. This is the basic property of chemical reaction. But on the other side, in case of nuclear reaction, not the electron, nucleus of the atom takes part in the nuclear reaction. Nucleus means the central part of the atom which contains proton and neutron. It means in nuclear reaction, proton and neutron takes part in the reaction. And certainly, if nucleus takes part in the reaction, some other element forms. Okay, this is one of the basic difference between nuclear reaction and chemical reaction. In one of the reaction, electron takes part in the reaction. In another reaction, nucleus of the atom takes part. Okay, let's go to another point. In the chemical reaction, the element which takes part in the chemical reaction or the compound which takes part in the chemical reaction, after the reaction, the element and the element contained in the compound remains same in the product also. What it mean? With an example, let's talk about example. When zinc reacts with hydrochloric acid, then in reactant side we have an element zinc. Hydrochloric acid means it contains two different elements, hydrogen and chlorine. And in product, what we get? Zinc, chloride and hydrogen. In product also, the same element zinc is present, same element hydrogen is present, and same element chlorine is present. It means there is no change in the element. Identity of the element remains same in the chemical reaction. But in case of nuclear reaction, one element converts to another element. Just for example, when hydrogen nuclei fuses with each other, then they form helium nuclei. No more hydrogen is present in this reaction. I mean to say hydrogen is used up and another element forms. Identity of the element changes. Different element forms in the nuclear reaction. Okay, let's go to another point. In each of the chemical reaction, either the energy produces due to the chemical reaction or energy is absorbed in the chemical reaction. We can take example also. Just for example, when zinc reacts with hydrochloric acid, then zinc chloride and hydrogen forms. In this reaction, heat energy produces, a little amount of heat energy produces. We can feel it if the reaction is carried in a beaker. In the same way, when carbon bonds in atmosphere, it reacts with atmospheric oxygen to form carbon dioxide. In this case, certain amount of heat energy produces which can be utilized for different purpose. In this reaction, heat energy is produced. But there are some other reaction in which heat energy is absorbed also. Just for example, in the process of photosynthesis, light energy is absorbed by the plant, and the photosynthesis reaction occurs due to which they become able to produce glucose in the leaf. But on the other side, nuclear reaction is quite different. In every nuclear reaction, tremendous amount of heat energy, tremendous amount of energy produces. When hydrogen fuses with each other to form helium, which is constantly taking place in the sun, tremendous amount of energy is being produced. That energy we are getting and we are using that for different purposes also. In the same way, when uranium atom is bombarded with neutron, it disintegrates into barium and krypton. In this is a nuclear reaction. In this nuclear reaction also, tremendous amount of energy produces that is utilized to run a nuclear power plant. Now let's go to another point. A chemical reaction can be reversed under suitable condition. Just for example, we can take one example, very easier one. Nitrogen combines with hydrogen to form ammonia. And this ammonia again decomposes. We can decompose ammonia into nitrogen and hydrogen gas. Under certain condition, we can reverse the chemical reaction. But nuclear reaction cannot be reversed. They are irreversible reaction. Hydrogen nuclei, when combined with each other to form helium, helium cannot be reversed to form hydrogen again. This way, one is reversible under certain suitable condition. Another is irreversible. Okay, let's go to fifth point. Different elements have isotopes. Just for example, hydrogen has got different isotope: protium, deuterium, tritium. And this isotope, when takes part in the chemical reaction, they give the same product. Because isotope means they have same number of electron, but different number of neutron in its nucleus. And since in chemical reaction electron takes part, that's why all the isotope gives the same type of reaction. But the same isotope, when undergoes nuclear reaction, then it gives different product. Just for example, when protium combines with another protium, it forms deuterium. And when deuterium again reacts with another protium, then it may go to tritium. And tritium and protium again may combine with each other, and another result, that means helium, can form. It means the isotope of same element gives different nuclear reaction, but isotope of same element gives the same type of chemical reaction. Okay, these are the 5 basic differences between chemical reaction and nuclear reaction. Okay, this much for today.